All right, finding the missing side on a triangle using trigonometry. So that's what we're going to do today. This right here is set up just kind of as a review. If you had to find sine of A, hopefully you could do that using SOHCAHTOA. Sine is opposite over hypotenuse, the S-O-H. And if we're dealing with angle A, that's the one over here. So which side is opposite of A? Well, it's probably easiest to start with which side is the hypotenuse. The hypotenuse is always the longest side, which is the diagonal side across from the right angle. Now, which one is opposite of A? It's either 1 or square root of 3. You got a 50-50 chance here. Square root of 3 is part of angle A. That's adjacent to it. The one that's opposite is not part of the angle. So 1 is opposite of A because the side 1 does not make up angle A. It's on the opposite side of the triangle. So that's your O, that's your A for opposite, adjacent, and hypotenuse. So you've got 1 over 2, 1/2. That's review. You guys seem to do pretty well on that yesterday. Now we're going to solve for a missing side. So I'm going to erase the 2 and just put an X there and say solve for X. So now I'm not telling you that the hypotenuse is 2. We have to figure it out. So you're going to start off the same way. You're going to use sine of A is opposite over hypotenuse, and that would be 1 over X in this case. So sine of A is 1 over X. So let me rewrite that without the OH in the middle. OH for Ohio State Buckeyes, by the way. All right. Sine of A is equal to 1 over X. If we had to solve for X, we wouldn't be able to do it in this situation because we have two variables. We have an A and an X. It's kind of like this problem here. X plus Y equals 7. If I said X plus Y equals 7, what does X equal? I'd get a lot of different answers. People might say, well, it's 5 plus 2, or it's 6 plus 1, or it's 4 plus 3. You'd all be right, but you don't know for sure. My point is, you can't solve for a variable if there's two of them in the same equation, because then you have a lot of different combinations. And that's what we have here. We have an A and an X, two variables. There's no way to solve for the missing side in this. Some of you at home, I'm sure, are saying, use Pythagorean Theorem, which you can do. So let me erase the 3. Now you can't do Pythagorean Theorem. All right, so how are we supposed to do this? You need more information. You need to know how many degrees is angle A, and you will be given all that information today. So that's going to be that's the two things that are going to look different in today's problems, is that you're going to be given an angle measurement and you're going to be missing a side. Now you can solve for this problem. We substitute out the A for 30. So instead of sine of A is equal to 1 over X, it's sine of 30 because A is 30. Angle A is 30 degrees. Now you can solve for X, but you have to use some algebra here. And this is where a lot of mistakes happen. How do you solve for X in a problem like this? Let me give you an example. Let's say 8. That was a terrible 8 I just drew, so I'm erasing it. 8, oh, that's pretty, is equal to 2 over X. A lot of people would say, oh, X is 4. You would solve this because you would divide 2 to the other side. No, X is not 4. That's not how you solve for X on this one. You have to get X in the numerator before you can solve for X. X does not equal 4 in this. How do you get a denominator into the numerator? You multiply it to the other side. You move it to the other side and it goes to the denominator. Basically, you're multiplying by X on each side of the equation. These X's will cancel out and you're left with 8X is equal to 2. All right, multiplying by X on each side of the equation is kind of the technical way to do it. Really, the way I like to explain it is just get that X out of the denominator by moving it to the numerator. And when you move it to the numerator, it has to go to the other side. Basically, you're moving X to the other side, and it's going into the numerator, so it becomes 8x equals 2. Maybe it's easier to explain what I'm doing if I show you something like this. X over 3 equals 5. Say we had a problem x over 3 equals 5. How would you solve for x? You would multiply 3 to the other side, and you'd say x equals 15. X equals 15 in this problem. You multiply the denominator to the other side when you're trying to get rid of a denominator. It's the same concept here. You want to get the denominator to the other side. The reason you want to do that is because we want to solve for x. And to solve for x, x has to be in the numerator. We're not solving for 1 over x. We're solving for x. If you were to just divide 2 to the other side in this problem to get x by itself, you would have 4 is equal to 1 over x. We don't want 1 over x. We're not trying to solve for 1 over x. We're trying to solve for x. All right, so you multiply x to the other side, you get 8x is equal to 2. And then to get x by itself, you divide by 8. 2 divided by 8 is 1/4. So x was actually 1/4 in that problem. Essentially, I skipped a step because I figured you could do 2 divided by 8 in your head, but you end up with x is equal to 2 over 8. So look what happened here. You multiplied x to the other side and you divided by 8 to the other side. They basically switched places. X went to the 8 spot, 8 went to the x spot. See how they switched spots here? That's the same concept on solving for x here. We're going to multiply x to the other side, and then we're going to divide sine of 30. So you're going to have x times sine of 30 is equal to 1. That's the first step, multiplying x to the other side. And then divide the entire sine 30 to the other side. So you end up with x is equal to 1 over sine 30. So just like the example I showed you, the x and the sine 30 switched places. X was in the denominator, sine 30 was over here. Now sine 30 is in the denominator, x is over here. That's how you solve for x. This is what x equals. Now to get the actual number, you have to use a calculator. So you get out your calculator and you turn sine 30 into a decimal by just hitting sine 30 on your calculator. And when you do that, you'll get 0.5. The sine of 30 is 0.5. So you have 1 divided by 0.5, and 1 divided by 0.5, how many times does a half go into 1? Twice. So x is equal to 2. So lo and behold, x was actually 2 when the angle of sine is 30. All right, sometimes they're not going to be that difficult, meaning that x is not going to be in the denominator. Sometimes x will be in the numerator. For example, let's say we had, this was 2, and this was x. Let's say our problem looked like this. We would use, say, sine of 30 is equal to x over 2. Now to solve for x, x is already in the numerator, which is good. This was just like the problem x over 2 equals 5. X is equal to 10. You just multiply 2 to the other side. So that's what we're going to do here. To get x by itself, you're going to multiply 2 to the other side, and you get 2 times sine of 30. And sine of 30 is just a decimal. All sine, cosine, tangents are just decimals. So it's 2 times some decimal. Sine of 30 we just figured out was 0.5 with our calculator on the last problem. So it's 2 times 0.5, which is 1. So x is equal to 1. So if you get a problem where x is in the numerator, it's a little bit easier to solve algebraically. But if x is in the denominator, it's not that bad. You just switch it, like we did in the last problem. All right, where it can get kind of tricky, and this is what your problems are going to look like today, is you're going to have 2 variables for your sides. They're only going to give you one side. And you're going to have to solve for the other 2 sides. So to solve for y here, sine isn't going to help you. If you do sine of a, you're going to have an x and a 2 in your problem. You're not even going to have a y. So you can do sine to solve for a like we just did. But how are you going to solve for y? You're going to have to use either cosine or tangent. So that's the tricky part in this. You're going to have to decide, are you using sine, cosine, or tangent? Well, you definitely cannot use tangent to solve for x and y here, because if you use tangent, you're going to have tangent of 30 is equal to x over y, because tangent is opposite over adjacent. So tangent of 30 is equal to x over y. And now we're back to the x plus y equals 7 thing. We have two variables. You can't solve for a problem with two variables in it. You can't have an x and a y in the same problem. So we can't use tangent because then we're getting both variables in the same problem. So to solve for y, you got to have 2 as part of your fraction. And to get y and 2 in the same fraction, that has to be cosine of a, because y is the adjacent, 2 is the hypotenuse. What uses adjacent and hypotenuse, SOHCAHTOA? Cosine does. Y over 2. So there you go. Cosine 30 is y over 2. You multiply 2 to the other side. Cosine 30 is equal to y. So it's 2 times some decimal cosine 30, which, let me see, I'll pull up the calculator real quick here and tell you what that is. Cosine 30 didn't work. Oops. What's wrong with my calculator? Oh, you have to hit cosine you have to hit 30 first and then cosine on my calculator. All right, so 0.86. So it's 2 times 0.86 is equal to y, and 2 times 0.86 is 1.73, which is essentially the square root of 3. If you took the square root of 3, you're going to get a decimal. It looks almost exactly like that. All right, so that's what today's problems are like, solving for a missing side. Decide if you're using sine, cosine, or tangent, depending on what variable you're solving for. And then do the algebra to get your x or your y all by itself in the numerator. The end.